So here the 5 goes into 50. 10, so I get 1, 10. 3 goes into 12. 1 times 1. 4 times 10. 1. I'll do this problem here in a minute. So what about the second number 2? All right, this should be easy enough. I don't want to see this, by the way. There's 2 problems with that. It doesn't really tell me the answer. It looks more like you're checking, and I'm not sure what you're checking because you haven't done any work. Guys, so the work I need to see is this step here. That's the algebra step.
X equals 6.
I like it. And then you can always check it next. But don't have a number come out of nowhere. Just because it works and just because it's the right answer, it doesn't mean you're going to get the points. Because this is algebra class, you have to show me the algebra. This is not guess and check class. Right? Let's see. Everybody got this here?
Yeah.
So this is where you guys really have to be more nice to yourselves. Math is hard enough already, and some of you guys are just making it harder. I don't know why. You want to increase the level of difficulty. Here I don't have any parentheses, so there's no distribution to do. I can just start moving my x's and my numbers. So which way do you want to move the x's?
Minus 3x.
So this is still here.
It equals 2x plus 2.
And very often when people do this, they forget that minus. Of course, that sucks a lot because it's one little thing that's going to totally throw off everything else. So don't forget that little negative is attached to the 8.
Right.
Now I brought my x's that way, so I want to bring my numbers the other way.
So minus 2.
Minus 2. And then the last step is almost always
Divide by 2.
divide.
X equals 9 minus.
Negative 5.
Cool. Oh yeah, this is the one.
Yeah.
I'll do this 2 different ways. All right, the first way is the way that once you get used to it, when you have a much more complicated equation with fractions in it, it's pretty much the way you want to do it. Now this is not that complicated yet, so you can keep the fractions here if you want to. But what I highly suggest you get used to is, what's the LCD of everything?
9.
9. So if you multiply each piece by 9, the beautiful thing about that, and don't multiply the bottom by 9 also, right? Then you're really, guys, right here. So right here now you can cancel. That's the beautiful thing. The next step should have no fractions left. That's the whole reason I'm doing this, is to kill the fractions. Why am I allowed to kill the fractions here exactly? Why am I allowed to do this?
Because you just multiply by 9.
But why am I allowed to do this specifically?
Because fractions is being divided by.
In order to make it x times
Why am I allowed to do it though? Because it's in equation.
Oh.
I have 2 sides. If that was not there, you can't just multiply it by 9 out of nowhere. I don't like fractions. Let me make it no. Right? So if I give you a problem like 1/7 minus 3/14, you can't just multiply by 14. Yay! Right? You understand? Because once you start to see I could kill fractions, you want to do it everywhere, and I don't blame you. But it's the equation that makes it legal. I've got 2 sides. It'll balance. If there aren't 2 sides, what the hell's going to balance? You're just piling the side on with shit. You can't do that. You got to have 2 sides to balance. So here, the 9's go away, thank God. So I get 2x. 3 goes into 9. 3 times 5 times 3. You guys see that? And 3 goes into 9. 3 times 4x. And now that looks beautiful, yeah.
Okay, so why don't you multiply the 9 by the 2 and the 9 by the...
I could.
Okay.
9 times 2 ninths is 18 over 9, which is
I'm sorry. Oh, to reduce it. Oh, I see.
which is 2. So it's better to do this and get to the 2 directly.
Okay.
Yeah. Because you either kill the 9s first or you kill the 9s last. I'd rather kill them first when I can see them. Yeah. Cool. And now here, this should not be a big deal at all.
No X.
Yeah, I definitely want to move the x's because the numbers are all together already. Yeah.
Minus 10. X equal
Divide by 10.
Yeah, divide by 10. And here you could either make it a decimal or you could reduce it and make it
minus equal
fraction, right? Either way. Don't leave it 15 over 10.
what?
If I don't say though, you can either make it a reduced fraction or you can make it a decimal. I don't care if I don't say. Okay.
You can't say 1. Minus 1 over 1.
Oh yeah, you can make it negative 1.5. You can make it a mixed number.
Yes.
Cool.
Well, then not.
Oh, I did say I'd do that 2 ways, didn't I? The other way to do this problem you could subtract 2 ninths x,
Work this out.
get your x's together, so you can just leave the fractions there. Now you can't do these. You have to get it straight, Jeff. Multiply this by 3 here, right? So you get, that goes away, there's your negative 5/3. Here's your 12 ninths minus 2 ninths is 10 ninths. You with me so far? And then here, if you want to, you could cross multiply.
When you multiply by 3 over there, that was so that you can get the LCD?
LCD, because they can't subtract fractions unless they have the same denominator. Right? So if you leave your fractions there, you're probably going to have to do some LCD work that way. Here, divide by 30, and that reduces to the same thing. Yeah. So it all depends on how comfortable you are with fractions. When you have an equation, you have the option to kill fractions, you have the option to kill decimals. You don't have to, but you can. So either way you want to do that. So 2D, the second 2D. So again, to be really nice to yourself, I saw enough people doing this. Decimals, I'm okay with keeping them the way they are.
I don't like this.
Because I don't have to worry about LCDs. You could multiply everything here by what?
100.
By 100. And then you would get 5x minus 11 equals 34 plus 4x. Which I don't blame you, that looks pretty nice. Do you guys see where I got that from?
Yes.
If you multiply everything in here by 100, how many times does the decimal move? Twice. So that's why I picked 100. Because if everything moves over twice, they all become whole numbers. So if I had 0.051 here, I'd have to multiply by 1,000, so I can move it over 3 times. So then everything would move over 3 times. But if I leave the decimals in there, what do? The process doesn't care. The math process does not give a crap what's in here. It says get your variables on one side, get your numbers on the other. So here I can subtract to get my x's together. Show yourself this, dear God. Too many of you guys would put here 0.09x without showing yourself anything. And I'm like, how did that 4 get the well over here? You've got to show yourself. And then you can see, oh yeah, I can see this cancels. If you can't see it canceling, don't do it. It must be something else you have to do, right? How can you see it canceling if you don't show yourself what the hell's going on? So here I get Yeah, 0, 1x. Yeah, over here you would get x here. Minus 0.11. And then of course next, what would I do?
You wanna,
Plus 0.11.
Yeah, I want my numbers to go the other way. So plus 0.11. So 0.01x equals 0.45.
45.
And here's the really cool thing. Yeah, you will divide, but actually you can just do this. So one person do that, because you multiply both sides by 100 then. So see, here you multiply both sides by 100 first. Here I multiply both sides by 100 last. Math says, I don't care when you do it, just do it sometime.
X equal 45.
X equals.
But to see a little more directly, you would divide by 0.01. And then here you can do it for yourself. 45 divided by 1, 45. Yes, ma'am.
I got 4.5. 0.21.
But you got 0.45 here, right? Uh-oh, all right. Did you multiply, did you move the decimal out first? Show me later. Okay. But what I really desperately want you guys to realize, no matter if there's decimals or fractions, the process does not change. Get my x's together, get my numbers together, almost always divide last, right? The process doesn't care. We care though, we are, oh crap, it's uglier now, there's decimals, ah. But math is like, x is one side, numbers, it doesn't care. Okay. Hopefully. All right. So then we get to E. Oh. Okay. Now, one thing you can do for yourself to make it easier, no matter which way you do this, is this has two places and some of them only have one. So I'll do this, and if you like it, great. If you don't need to do it, don't do it. But I would, to make it easier myself, add some zeros. Now they all have two places. Right? So now you're not going to make a mistake. If you multiply by 100, you're not going to not move it over enough. Everything's going to go over twice when you do that. Or when you start adding, subtracting these, you're not going to put them in the wrong place. You've given them all the same number of decimal places already. You're good to go there. So no matter what I do, what's the first thing I have to do here? Yeah. Twice 0.05.
Is 0.1.
Yeah. And then twice 0.03. I mean 0.30.
Is 0.6.
0.60. And now it's a little bit easier to put those together. They have the same number of places here. So negative 0.60 minus 0.11.
It's gonna be negative 77. Make 0.77.
71.
Oh, 71. Sorry. That's what I meant. Move it down.
Okay. You doing okay so far? And I don't know if you guys see it like this, but when I look at this, I see 60 and 11. That's 71, put a negative on it, and I put the point because they both had a point there. That's how you can look at it. This is just 60 and 11. That's 71. It's negative because they're both negative. And then put the point back in there, 0.71. Decimals really aren't as evil as they seem they could be. They're not. Okay, so now I'm kind of like in the same place I was here. I pick a way to go with my x's. What do I want to do with my x's here? Get them on one side. So be more specific. What can I do to both sides?
Subtract the 10x.
Good.
0.10.
So there they cancel. That's still here. Here I get 0 point.
It's 1, 0.
And so I moved my x's that way, so now I want to move my numbers the other way. My umbers. Some little kid, I want some spaghetti. And my numbers. Okay, so it's 71 and 15. They're both negatives, so I'm going to add them. So 86.
Oh,
Put the point back on, and it's negative. Over here they cancel, so I just have the 0.10x here. And the last step almost always is divide. Oops, got there, Joe. So move this over once, move this over once. 8.6 negative. So when you divide, the shortcut is when you divide by 1, it stays the same. When you divide by 0.1, the decimal moves over 1, makes it 1 bigger. Divide by 0.01, it moves over twice. 0.001, 3 times. Okay. So when it's a multiple of 10, when it's some power of 10, 10, 100, 1,000, or tenths, hundredths, thousands, then operation should be easy because our number system is based on 10. Yeah.
So then you don't need to see us do the division, 8 goes into.
I'll tell you, on the test, I'll tell you for sure one or the other. On the test, I'll probably have a set where you show me all the work, and probably on the equations, I'll be cool with you not showing me quite as much work. But I'll be very clear. On the quiz, I wanted work everywhere. Yeah. Or the last thing we did, the last test. Oh yeah. Let me see if I can do this somehow. So 7/20ths. The beautiful thing about 7/20ths is I can make it out of, what do I really want on the bottom there to make both percentages and decimals easier?
Multiply by 1.
Yeah, I want some 10, 100, 1,000. Yeah, so multiply by
5.
5. So that's 35 out of 100. What is that as a percent?
35.
35%, because percent means out of 100. And then the decimal I can do one of two ways. 35 hundredths. I want the number to end up in the hundredth place. The last digit better be here, so there it is. Or, to make a percent to a decimal, I move the decimal this way. They both, thank God, make 0.35.
Or I can divide it on 100.
Or you could do this division. Yep. But the reason we made it out of 100 is to make these easy. I shouldn't have to do that long division. So the next one, so this is 0.04 now. So what is that as a percent?
4.
Good, because you move it over once, twice that way. So again, something else I really want you to get out, I've said this several times, process does not care what's there. To go from a decimal to a percent, I move the decimal that way twice. I don't care what this number is. So many of us get wrapped up on that number. No, I just move it over twice no matter what it is. And then I can make a fraction very easily. That's 4 in the, what place? Hundreds place. Or this is 4% per 100.
100.
And again, they both match up at 4 over 100. You can reduce that if you want to, but I definitely want to see that so I can see where it came from. If you reduce it, it would be, but I don't want to have that just show up because that tells me you did it on the calculator. That tells me you figured out your fraction buttons on the calculator. The calculator passed the problem, you don't. So what do I hear? 78%. So again,
All 0.78.
yeah, so this is going to go back once, twice. And now I have two ways to get the fraction. This is in the hundreds place. Percent means per 100, so they both end up at 78 over 100. And you can reduce that if you want to. Is that okay? So this one now, this is where I start getting people worried, because you see that 2,340, you're like, oh. But the process doesn't care. When I go from here to here, I move the decimal back. So what should this be now?
23.4.
Good, because I moved the decimal once, twice back. Now I've got two ways I can write this. And again, this is where people start to worry about the 2340. What does percent mean? Per 100. So I can just put the per 100. That's what that means. And what goes on the top? 2340. Or you can write, what's this? 23 and 40 hundredths. These are the same. 100 times 23 is 2300 plus 40 is 2340 over 100. Those are the same. So whichever one you put is fine. Yes, ma'am.
Okay, so why wouldn't you do 23400 over 10?
Yeah, I could kill the 10. I could reduce it now,
You
sure.
could do that.
Yeah. And then you can reduce it further because 2 goes in. But I'm not testing you on reducing fractions right now. So that's why I'm okay if you don't reduce it. I'm testing you on do you know how to convert from one to the other. So I'd actually much rather see this because I could see where it came from then.
Okay.
If I let you reduce it, people might just put only that, and then I won't see where it came from.
Well, I just left off the 0 because at that point it didn't have any purpose.
Gotcha. I agree with you. Because you could do that, yeah.
Okay, I just
Cool.
want to make sure.
Well,
See, let me put this up here.
0.5.
What about this guy here?
2 point.
Once, twice,
No.
right? Again, the process does not care what's there. I move the decimal that way. And as a fraction, what would that be? It's a little easier to see here. Tenths, hundredths, thousands, 10,000s. Now to show you this would be a little freaky. This here would be a little bit freaky. That would be 0.12 over 100. I don't like that. Do you know why I don't like that? Is that decimal or fraction? Yes? Wait. That's an or question, right? So I can't have a decimal inside a fraction. I'd have to move this over once, twice.
Yeah.
So on the bottom I have to move it over once, twice. And there you go. Now they're the same.
Yeah.
So I'd much rather, in that case, get it directly from the decimal then. If I have a decimal percentage, get your fraction straight from the decimal itself. You're not going to have that internal decimal weirdness. 0.12 over 100, that's freaky as hell. I'd rather just go straight from here. Okay. Oh yeah, this is the one that definitely had people freaking out. I didn't know what to put down to round it to. But you do this 1, 7, 1, oops, where'd it go? Yep, 1, 4, that's plenty. So then the next one's gonna be 2. So it's 1.714 as a decimal. And then what is it as a percent then? Once, twice, 171.4%. Maybe.
If we just keep it to 171.
That's fine. If I don't say, I can't really complain. Yeah. But notice something real quick. 100% is what as a decimal? 1. As 100% is one whole thing. This is bigger than 1, so this should be bigger than 100%. This is way bigger than 100%, so this should be way bigger than 1. I mean, it kind of makes sense. Every now and again, math makes sense. Let's see, what do I? 0.564. This is where I get people that go the wrong way, but the process doesn't care. Which way do I move the decimal? Back twice. So it becomes 564. You can do it, Jeff. Once, twice. So 0, 0. This is a crazy small percentage, so it should be even a crazier small number. And now, what is this as a fraction? Tenths, hundredths, thousands, 10,000s, 100,000s. Okay. All right, so like I said, you definitely expect a problem just like that on the the test. And finally, we got these two little problems here. Number 4. So to me, the easiest way to do this problem is just to make it directly into an equation. 11 is equals what percent, I don't know, of means multiply 31.8. And then I'm one step away from figuring it out. So here I just have to divide to get the x by itself, right? So it's really nice. The equation you're going to get from any statement like this is going to be one step away from being done, at most. So x equals,
2.89.
I don't think so.
0.34.
3, 4, 5,
Yeah.
roughly.
You could round it.
And what's that as a percentage? Yeah, once, twice. To me, the easiest thing to remember is percent number is always bigger than decimal number. Percent number bigger than decimal number. Percent number bigger than decimal number. It's a real quick check you can make. See? Percent number bigger than decimal number. So what about number 5? 3.3 is 14% of what? 3.3 equals 14% is 0.14 of what? I don't know. You don't have to put parentheses there. I don't know why I did. I just did. And then what do I do to solve for x?
Divide.
X equals whatever the hell it has. 20 something.
23.7.
Now, is that a percentage answer? I know it's not, because there's my percentage. This number is this percent of what number? So I should end up with a number. So I leave that alone, that's the number. Does it make sense? Well, what's 10% of this? What's 10% of 23? 2.3. So 14% of 23 should be a little bigger than that, so it does kind of make sense. So I can kind of make some sense out of this. It's not intuitive to us yet, because we don't do this a lot. But you can kind of gauge if it makes sense. All right. So, actually, that's pretty much enough for today. So, if you have questions, hang up.
I totally zoned out, I was trying to do it, but you did .14.
Yeah.
And you wanted to get the.
Because 14%, remember, percentages are things we made up. What really is 14%? 0.24.
How come we didn't do that from 31.8?
Because 31.8 is not a percentage. It's a number. So it's what percentage? I don't know. So here at the end, I had to kind of move it over.
I see.
Here at the beginning, I got to move it back.
I got you.
What's up? Oh, the bonus. I forgot. We'll do that next time.